Hey everyone, so today we're going to be talking about the basics of an atom. And so we'll just be going into a overview of the atom. We'll start off by talking a little bit about what actually an atom is, talking about the particles that compose the atom. Then we'll finish it all off by talking about the atomic theory, where we were at, and what we've come to today. So without a further ado, let's go on to what is an atom. So what exactly is an atom? It's the smallest building unit of matter that retains its identity. So let's break this down. It's the smallest building unit of matter. But if you notice when I was mentioning earlier, there are particles that make up an atom. So in reality, it's probably not the smallest one. And so that's why we've added the second part, which talks about it retaining its identity. That's really important because what we're saying is that the particles don't have their own identity unless they're put together and make up this atom. So there are smaller particles, but they won't maintain their identity. So that's what makes the atom unique in it being the smallest building block or building unit of matter. And so what really makes up this atom? So we have protons, which are the positive particles in the atom, weighing around 1 atomic mass unit. And so an AMU is just the measurement that we use for particles, the weight measurement, right? And so it has a positive charge. It's the positive particles in the atom. And then we have the neutrons, which are the neutral particles in the atom. They also weigh around the same way as a proton, but if you are asked this question, they weigh slightly bit more than a proton, so a little bit greater than 1 atomic mass unit. And they have no charge. So they are, like their name says, they have neutral charge. So then we have electrons, which are the negative particles found in the atom, really, really light with a negative charge. So how exactly were these found, right? So the first one to be found was the electrons, and they were found in this project known as the cathode ray experiment. Again, you can search these up. Feel free to reach out to us with questions, but I won't be going too much into that. And then we found protons through a famous experiment known as the Rutherford's gold foil experiment. Again, I won't be able to go into that for this video. Then we found neutrons later in another experiment, and we kind of solidified them as the particles that make up the atom. And so the next question that we had to ask was, where are these particles located in the atom? So where are they? So what we knew was that the protons and neutrons were in the center of an atom, in the center, in this little place known as the nucleus. So the nucleus is sort of like the headquarters for the atom, and so the protons and neutrons were just mingling in there, and so that's what we knew. But the real question was, where were the electrons in the atom? And so we didn't know about this. So we started off with the chocolate chip cookie dough model. This is a model proposed by someone just to maybe kind of put something out there for where the electrons might be. And so it kind of said that electrons were stuck on the nucleus like chocolate chips in cookie dough. And so the green dots, just for the sake of this picture, represent the electrons, negative electrons, and they were sort of stuck in there just around the nucleus. We accepted that this was not true, but we didn't know what else was out there, so this was widely accepted for a while before we came to a better model that is known as the orbit model, proposed by Huntaro Nagaoka. I'm so sorry for the pronunciation, but it suggested that electrons were in a sort of orbit around the nucleus in a electron kind of cloud. We also established the organization of these electrons, how they were structured around there. It wasn't just random, but that'll again be mentioned in another video. They were in a sort of electron cloud around the nucleus in a sort of orbit, the same way we have like our planets orbiting the sun. And so we had the orbit model, which was widely accepted, and this was the model that we use till this day. And so then we had to like put it all together. We had all these particles, but really what was an atom and what were its properties, right? And so that's what the Dalton's atomic theory answered. So Dalton came up with this theory that was way ahead of its time, and it's most parts of it are still widely accepted today, and so it had 5 parts. The first part was that all matter is made out of atoms. And this part is still true today, and so that was absolutely correct. Second part was that all atoms are indestructible and cannot be broken down further. So this was somewhat right. We revised it a little bit later because it wasn't absolutely correct. Third one was that atoms of one element are exactly alike, but different from atoms of a different element. So again, this is somewhat alike, and I'll explain that a little bit later. Fourth part was that atoms combine in simple whole number ratios to form compounds. Absolutely correct, and so this is still accepted today. Atoms are combining in simple whole number ratios and they're creating compounds, something we'll talk about later in the videos. And then the fifth part was that chemical reactions occur when atoms combine, separate, or rearrange. Sorry for the extra comma right there. This was also right, but we revised the second and third ones a little bit. So we had a little bit of an issue with this part of the second one. And so we revised it to say that atoms can be broken down into smaller particles but would lose their identity. Remember, we were talking about protons, neutrons, and electrons, and going back to the definition of an atom, atoms are the smallest building blocks of matter maintaining their identity. So these smaller particles would lose their identity if they split apart from the atom, but when put together, they would make up the atom. And so this is how we kind of revised the second one, because it was not completely correct to say they were indestructible because they could be broken down. And for the third one, this is a little bit more simpler in which part was right and wrong, but we completely agree that atoms were different from the atoms of a different element, but we had to revise the first part. That's because we had a couple more discoveries that we had a little bit later after Dalton's atomic theory. So what we said instead was that all atoms of one element are very similar, and they're still different from atoms of another element. And this was due to the discovery of isotopes. So we had carbon-13, carbon-14, carbon-12. This was because they had different numbers of neutrons in the atom. And so we found this later, but they're very, very similar to each other, had similar properties, but just because they were a little bit different, we couldn't say that they were completely the same. And so the first, fourth, and fifth part were still right and are still accepted today. And that's how we came to the atomic theory, which helped us put all this material about the atom together and really solidify this theory. And so that's all that we have for today. If you have any questions, any comments, feel free to comment on this video or reach out to us through the form on our website. Be sure to look out for other videos that we have coming out and for our virtual classes that are coming soon. Thank you guys, and bye.